history, the first industrial revolution mechanized manufacturing. Engine-driven steel machines replaced slow, piecemeal manual labor, delivering vastly more work with repeatable quality. Then the second industrial revolution automated manufacturing. Optical sensing, robotic arms, and computing all contributed to a whole new level of speed, accuracy, and efficiency. Digital blueprint information now drives CNC machines. Precision automation reached its pinnacle when it created silicon chips, and the information age was born. The drive to automate land-based manufacturing has had to confront much vaster scales. Every location and project is unique, and maintaining a common reference for all the earthwork at a site has always been a tremendous challenge. However, the evolution of the positioning industry has unlocked the potential of automation for these industries. Unique technologies have combined to allow us to machine the face of the planet automatically. Three-dimensional positioning, combining GNSS satellite signals with computer modeling, now drive the automation of heavy machinery. But how does this technology work together with your existing tools to deliver the power of automation? Let's go through each phase of the job site and see. Capturing the existing terrain can be done with a combination of technologies, from satellite imagery and aerial surveys to precision topography for critical project areas using RTK GNSS, robotics, or high-speed collection with the newest mobile mapping systems. Topcon's mobile mapping system is pointing the way to the data collection of the future. With a combination of 360-degree imaging, satellite position, and laser scanning, it can collect 3D survey data from a moving vehicle, making massive, precision data collection possible. Once the existing terrain is measured, the next step can be carried out: designing the new area. Using software like Magnet Office, three-dimensional plans are created based on the existing area, with special calculation tools to balance the cut and the fill. These 3D plans are transformed into usable data for machines, machine planning, and prediction of the site budget. On site, many machines work on various parts of the road at the same time. Every machine works individually, and traditional methods provide only limited site intelligence. So how do we bring this 3D site plan into reality? Each machine needs to first be equipped with a 3D machine control system. The system on each machine is able to read the 3D plans and combine satellite positioning to know where it is, and very importantly, they communicate with each other and the office. If we look, for instance, at an excavator, sensors are mounted to measure movements of the arm and bucket. A satellite receiver calculates positions within centimeter level. All this information and the 3D site plan go into the operator's display. This display gives the operator 3D intelligence right at his fingertips. For each machine, different configurations of the system are available to serve the need for every application. For instance, for dozers, we've developed a sensor that uses rocket science technology and algorithms to measure the blade movements 100 times per second. Using this technology leads to extreme accuracy. 3D technology increases the speed and accuracy of machine work on site. Speed translates back to time savings or more square meters of productivity, leading to greater accuracy and less material cost. Communications technology on each machine streams all of the changing terrain data back to the office, allowing us to monitor the amount of material moved down to the individual machine, again, all in real time. Another powerful feature is the ability to reach out to those operators and machines, to communicate, to update job files, and to provide remote troubleshooting and support. Current technology offers instant, bi-directional communication with each machine. One important tool that showcases this communication intelligence is the Task Manager. The task manager combines the office with the site in one single visual process. In the office, the site manager defines the activity for an excavator and dump truck. In this case, the excavator has to dig a water reservoir and should finish it within this week. The task, with the 3D planning data attached, is sent to the excavator. The operator opens the task and data directly on his screen. He accepts the task and starts working. Both the site manager and the operator have a constant status overview of the task. The status is based on 3D intelligence. Communication creates clarity on site, instant information availability, and speedy decisions. Combining all these elements together brings the modern job site to the dawn of the next industrial revolution. Improving the way we communicate on site. Having site data available at all times, in real time, improves planning and decision-making. Topcon, providing the tools to help you increase productivity, increase efficiency, and lower costs.